In the summer of 1931, a bankrupt mountain railroad placed its last hope on something that looked more like a joke than a machine. It was not a new locomotive. It was not even built by a major manufacturer. It began life as a used Buick passenger car, stripped down, cut apart, and mounted on steel wheels. This improvised rail vehicle cost barely $850 to build, yet it was sent onto a 130-mile mountain line, through snow, wind, and isolation, carrying the one thing the railroad could not afford to lose: the mail. Why would a failing railroad trust its survival to a car body on rails? And how did this desperate gamble briefly save an entire railway from extinction? By the early 1930s, the Rio Grande Southern Railroad was already living on borrowed time. Built in the late 19th century to serve the mining towns of Colorado's San Juan Mountains, the line stretched roughly 130 miles between the communities of Ridgway, Telluride, and Durango. For decades, silver and precious metals had justified its existence, but when mining declined and ore shipments dried up, the railroad lost the economic foundation it had been built upon. Geography made survival even harder. The line climbed relentlessly through high mountain terrain, with grades that punished machinery and crews alike. Winter storms regularly buried tracks beneath deep snowdrifts. Wind howled through narrow passes. Maintaining steam locomotives in these conditions was brutally expensive. Coal consumption was high. Water stops were frequent. Crews were large. Every mile traveled burned money the company no longer had. Then came the Great Depression. Freight volumes collapsed almost overnight. Passenger traffic dwindled to a trickle as automobiles improved and mountain roads slowly expanded. By 1931, the railroad was effectively bankrupt. It had entered receivership, and its continued operation depended not on profitability, but on a single fragile lifeline. That lifeline was the United States mail contract. Mail service paid a guaranteed fee for regular runs, regardless of how many passengers boarded or how much freight was hauled. For the Rio Grande Southern, this contract was no longer supplemental income. It was the difference between operating and shutting down entirely. Lose the mail, and the railroad would be forced to abandon its tracks, strand isolated communities, and erase itself from the map. But there was a problem. The cost of running steam locomotives to carry a few sacks of mail was greater than the revenue the contract provided. Each trip consumed coal, water, labor, and maintenance far out of proportion to the task. The numbers no longer worked. Every mail run pushed the company deeper into debt. Management faced an impossible choice. Either continue operating steam locomotives and bleed money until collapse was inevitable, or find a radically cheaper way to move mail through the mountains. Conventional solutions did not exist. New locomotives were unaffordable. Gas-electric rail cars from major builders were still costly and scarce. Credit was non-existent. Time was running out. The railroad did not need a powerful machine. It did not need speed or prestige. It needed something far simpler. A vehicle cheap enough to build, light enough to run, and reliable enough to operate in isolation. Something that could move mail and a handful of passengers without dragging the company under. The question was no longer how to modernize the railroad. It was how to keep it alive for one more season. And in that moment of desperation, conventional engineering logic was set aside. What kind of machine could possibly meet those demands? And who would dare to build it with almost nothing left to lose? The idea that would become the Galloping Goose did not come from a boardroom or an engineering department backed by deep pockets. It emerged from a small railroad shop in Ridgway, Colorado, where survival mattered more than tradition. The men responsible were not chasing innovation for prestige. They were trying to prevent total collapse. Two names appear repeatedly in the surviving records and recollections: Forrest White, the Rio Grande Southern superintendent, and Jack Odenbaugh, the railroad's master mechanic. Neither was a celebrity engineer. Neither had access to research laboratories or factory-scale production. What they did have was an intimate understanding of the railroad's daily reality. They knew how much coal a steam locomotive consumed on a winter climb. They knew how many crew members were required just to move a few sacks of mail, and they knew the company could not survive another year of doing things the traditional way. White's motivation was brutally practical. As superintendent, he was responsible for keeping the line operational under receivership. Every decision was weighed against a single question: would this keep trains running tomorrow? Odenbaugh, working in the Ridgway shop, faced the same pressure from a mechanical standpoint. He had to make worn equipment last longer, improvise repairs, and solve problems without money. Together, they began to question an assumption that had governed railroading for decades. Why did carrying mail require a steam locomotive at all? The task did not demand pulling hundreds of tons. It did not require high speed. It required reliability, low operating cost, and the ability to move through snow and mountains without constant servicing. Automobiles had already proven something railroads were slow to accept. Internal combustion engines could be cheap, flexible, and surprisingly durable. Trucks and cars were beginning to erode short-haul rail traffic across the country. White and Odenbaugh wondered whether the very technology threatening railroads could also save one. Their motivation was not to replace steam across the system. It was far narrower: build one machine as cheaply as possible to handle mail service. If it failed, the railroad was likely finished anyway. If it worked, it might buy time. This was not innovation driven by optimism. It was innovation driven by fear and necessity. There were no lengthy feasibility studies, no safety margins designed for decades of service. The goal was simple and urgent: reduce costs immediately or shut down. With that mindset, the unthinkable became acceptable: a passenger car body, a gasoline engine, steel wheels bolted where rubber tires once sat. What mattered was not how strange it looked, but whether it could move mail tomorrow morning. How exactly did they turn that idea into a functioning rail vehicle? And what compromises did they knowingly accept along the way? The solution that emerged in Ridgeway was radical, not because it was complex, but because it rejected nearly every assumption of traditional railroad engineering. Instead of starting with a locomotive and simplifying it, Forrest White and Jack Odenbaugh started with the cheapest machine they could find and asked how little it needed to become a train. The base vehicle was a used Buick Master 6 passenger car from the mid-1920s. It was not chosen for elegance or performance. It was chosen because it was available, affordable, and familiar. The Buick's 6-cylinder gasoline engine was already designed for continuous road use. Parts were relatively easy to source. Mechanics understood how to work on it. In an era when railroads struggled to maintain aging steam fleets, this mattered. The first step was transformation, not refinement. The Buick's rubber tires were removed, and steel railroad wheels were mounted in their place. The car's frame was cut and extended to better distribute weight and improve stability on rails. The suspension was reinforced to survive constant vibration and uneven track. What had once been a road car was now permanently married to the railroad. This was not a gas-electric rail car in the conventional sense. There was no generator feeding traction motors. Power went directly from the gasoline engine through mechanical transmission to the axles. This limited tractive effort and speed, but it drastically simplified construction and maintenance. Fewer systems meant fewer failures. Simplicity was the point. Inside, the vehicle was stripped of luxury. Seating was minimal. Space was allocated for mail storage rather than comfort. Heating was basic, essential in the mountain cold, but far from generous. Noise and vibration were constant companions. The machine was not designed to impress passengers. It was designed to function. Cost controlled every decision. The entire conversion reportedly cost just over $850. In railroad terms, this was almost nothing. A single steam locomotive overhaul could cost many times that amount. Fuel consumption dropped dramatically. One operator could replace a full steam crew. Water stops vanished. Coal piles were no longer needed for mail runs. Of course, compromises were obvious. The vehicle could not haul heavy freight. It struggled on steep grades when fully loaded. Snow presented a constant threat, especially without the mass and momentum of a steam locomotive. To help, a small plow was fitted to the front, more symbolic than powerful. The design assumed that tracks would be cleared often and that runs would be carefully timed. Critics would later argue that the design was unsafe, underpowered, and improvised. They were not wrong, but they were also missing the context. The Galloping Goose was never meant to be a perfect machine. It was meant to be cheap enough to exist at all. When the first unit was completed, it was officially designated Galloping Goose No. 1. The nickname reflected both its awkward appearance and the way it rocked and bounced along the rails. It looked ungainly. It sounded wrong. It violated the visual language of railroading. But it represented something far more important. It was a calculated gamble that reduced operating costs to the bare minimum. If it could make the mail run reliably, it would justify its own existence almost immediately. Design on paper was one thing. Survival on mountain rails was another. The real test would come not in the shop, but on the line itself. What happened when this strange machine finally rolled out of Ridgeway and faced the mountains for the first time? Construction of Galloping Goose. Number 1 took place in the Ridgeway shop under conditions that would alarm any modern engineer. There were no formal blueprints. There were no standardized procedures. Much of the work was decided day by day, based on experience, intuition, and what materials happened to be available. This was not industrial production. It was improvisation under pressure. The shop crews cut into the Buick body with little concern for aesthetics. Structural members were reinforced where cracking seemed likely. Mounting points for the steel wheels were adjusted repeatedly as alignment problems emerged. Each change was tested by rolling the vehicle back and forth along short stretches of track. If something bent or loosened, it was corrected with heavier steel or cruder reinforcement. Precision mattered less than durability. When the machine finally rolled out of the shop, it looked like nothing else on American rails. The proportions were wrong. The stance was too light. The body sat awkwardly above the wheels, more like a road vehicle pretending to be a train. Even among railroad workers accustomed to odd equipment, it drew skeptical looks. The first trials were cautious. Initial runs were kept short, close to the shop, with tools and mechanics ready to intervene. Vibrations shook the vehicle constantly. At certain speeds, the entire body resonated, forcing operators to slow down. Braking distances were longer than expected, especially on descending grades. Track imperfections that a steam locomotive would ignore were felt sharply through the frame. Yet, something important became clear very quickly. The Goose moved, it stayed on the rails, and it consumed a fraction of the fuel and labor required by steam. Where a steam locomotive demanded a full crew, water stops, and constant attention, the Goose required only a single operator and gasoline. Encouraged, the railroad extended the tests. The Goose was sent farther into the mountains, climbing grades that had once required heavy locomotives. On steeper sections, speed dropped dramatically. The engine strained, but it did not fail. On curves and trestles, the lightweight vehicle felt exposed, especially in high winds, but it remained controllable. Winter was the true test. Snow had always been the great enemy of the Rio Grande Southern. Steam locomotives relied on mass and power to push through drifts. The Goose had neither. Early snowfalls forced crews to learn new operating habits. Runs were scheduled carefully. Track clearing became more critical than ever. The small plow mounted on the Goose helped only with light accumulations. Anything deeper required assistance or delay. Despite these limitations, the Goose began regular service. On June 1, 1931, Galloping Goose No. 1 officially took over mail runs between Ridgeway and Dolores. The sight was almost surreal. A vehicle born as a family automobile now carried federal mail through remote mountain passes, bouncing and rattling over rails laid decades earlier. Performance was not graceful, but it was consistent. Breakdowns were fewer than expected. When repairs were needed, they were simple. Parts could be sourced locally. Adjustments were made quickly. The very crudity of the design worked in its favor. Within weeks, the financial impact was undeniable. Operating costs dropped sharply. The Goose had already paid for itself. Every successful run strengthened confidence in the experiment. What began as a desperate gamble started to look like a viable operating strategy. Still, doubts remained. The machine was fragile compared to traditional equipment. Its success depended on careful handling and favorable conditions. One serious failure could undo everything. Would this improvised railcar remain a stopgap solution, or had the railroad stumbled onto something more durable than anyone expected? The success of Galloping Goose No. 1 was not measured in speed, power, or elegance. It was measured in survival. Within a matter of weeks, the little railcar had done what no steam locomotive could do at a comparable cost. It kept the mail moving, without pushing the railroad deeper into debt. For a company on the edge of extinction, that was everything. Operating expenses dropped dramatically. Gasoline replaced coal. One operator replaced an entire steam crew. Water stops disappeared. Maintenance became predictable rather than constant crisis management. Each completed run confirmed that the railroad could meet its contractual obligations at a fraction of the previous cost. Confidence grew quickly. The Goose was no longer viewed as an experiment, but as a template. Additional units were constructed using similar principles, each adapted slightly based on lessons learned in service. Some were built from different automobile bodies. Others incorporated modest improvements in weight distribution or cargo space. Collectively, they became known simply as the Galloping Geese. These vehicles transformed daily operations. Mail runs became more reliable. Light passenger service continued, where it otherwise would have vanished entirely. Remote communities that depended on the railroad for communication and supplies remained connected, even as the wider rail network contracted across the country. The Goose also changed how the railroad thought about efficiency. It demonstrated that not every problem required a large, powerful solution. Matching the machine to the task, rather than relying on tradition, could yield dramatic results. This lesson echoed beyond the Rio Grande Southern, even if few railroads were willing to adopt such unorthodox methods. For a time, the Galloping Geese became symbols of ingenuity under pressure. Visitors and rail enthusiasts took notice. The sight of a car-bodied rail vehicle navigating mountain curves was both amusing and strangely inspiring. It represented a refusal to surrender, even when logic suggested that surrender might be inevitable. Yet the very factors that made the Goose successful also defined its limits. It worked because demands were low and expectations were modest. It thrived in a narrow operating window where cost mattered more than capacity. Outside that window, its shortcomings were obvious. Heavy snow could still halt service. Mechanical wear accumulated faster than on purpose-built rail equipment. As road infrastructure improved and diesel locomotives matured, the economic advantage of the Goose began to shrink. The railroad had bought itself time. But time alone does not guarantee a future. The forces that had driven the Rio Grande Southern into crisis were larger than any single machine. How long could this fragile balance hold? And what would happen when the Galloping Goose could no longer compensate for a failing system? The decline of the Galloping Goose was not sudden, nor was it the result of a single failure. It unfolded slowly as the conditions that had once made the improvised railcars essential began to change. The very forces that had allowed the Goose to succeed eventually rendered it unnecessary. Road transportation improved steadily through the 1930s and 40s. Trucks became more reliable. Mountain highways were upgraded and kept open longer through the winter. Mail contracts that once depended on rail service were increasingly shifted to the road. As volumes declined, even the Goose struggled to justify its continued operation. At the same time, the limitations of the design became harder to ignore. The lightweight railcars were vulnerable to deep snow. They lacked the mass and power needed to push through severe drifts, forcing frequent delays or cancellations. Mechanical wear took its toll. Automobile components, never designed for decades of continuous rail service, required increasing attention as years passed. Dieselization also changed the equation. By the mid-20th century, small diesel locomotives and purpose-built railcars offered many of the same cost advantages as the Goose, but with far greater durability and capacity. What had once been a revolutionary compromise now appeared crude and outdated. Gradually, service was reduced. Some Galloping Geese were retired and dismantled. Others were relegated to secondary duties or seasonal operation. The railroad itself continued to shrink, shedding segments of track and abandoning communities it could no longer afford to serve. The end came not with drama, but with inevitability. In 1951, the Rio Grande Southern ceased operations entirely. Tracks were pulled up, equipment was dispersed or scrapped. The line that the Goose had helped keep alive for 2 critical decades was finally gone. Yet the consequences of the Galloping Goose extended beyond the fate of a single railroad. A handful of units survived, preserved by museums and collectors who recognized their historical significance. These survivors became tangible reminders of an era when innovation emerged not from abundance, but from desperation. The Goose also left behind a more subtle legacy. It challenged assumptions about engineering purity and scale. It demonstrated that under extreme constraints, unconventional solutions could outperform traditional ones in specific contexts. The lesson was not that improvised machines should replace standard practice, but that rigid thinking can be as dangerous as mechanical failure. The Galloping Goose did not save the Rio Grande Southern forever, but it delayed the end long enough to matter. It kept mail moving, communities connected, and a railroad alive during its darkest years. What then does this strange machine ultimately represent? A failure, a curiosity, or something far more meaningful? The Galloping Goose was never meant to be a masterpiece of engineering. It was not designed to set records, impress investors, or shape the future of rail technology. It existed for a far simpler reason. A railroad needed to survive, and every conventional option had already failed. By stripping railroading down to its most basic function, moving a small load reliably at the lowest possible cost, the Rio Grande Southern exposed a truth that is often forgotten in times of abundance. Engineering excellence is not always about building the most powerful machine. Sometimes it is about building the one that fits the moment. The Goose succeeded because it accepted compromise without apology. It sacrificed speed, comfort, and durability in exchange for affordability and immediacy. In doing so, it kept mail moving through isolated mountain towns when no other solution made economic sense. For 2 crucial decades, that was enough. Its eventual obsolescence does not diminish its achievement. The forces that ended the Rio Grande Southern were larger than any single design. Improved roads, changing logistics, and new technologies would have closed the line regardless of what ran on its rails. What matters is that the Goose delayed that outcome long enough to serve a purpose. Today, preserved galloping geese sit quietly in museums, their car-like bodies still looking out of place among conventional locomotives. They no longer bounce over mountain grades or rattle through snowstorms, but they continue to tell a story that feels increasingly relevant. When resources are scarce and failure seems inevitable, innovation often comes not from perfection, but from necessity. The Galloping Goose stands as a reminder that survival sometimes depends on asking a different question. Not what is best in theory, but what will work right now. And when faced with the same pressures, would we have the courage to accept such an imperfect solution? Or would we wait for something better and lose everything in the process?